Hi, everybody. How are you doing this afternoon? Still hanging in there? Yeah, we're still alive. That's good. Well, I'm really glad you come join me today. I'm here to talk to you about building decentralized apps on Android. So first of all, I'd like to see a show of hands. Who here has built a decentralized app? Please raise your hand. Looks like we've got 3 people. Okay. Who knows what a decentralized app is or has an idea? Okay, about half the audience. And who knows, of those of you that know what a decentralized app is, who knows why we want to have decentralized apps? Okay, so that's maybe 6 or 7 people. That's not too bad. Okay, well, let's get started. My name is Larry Salibra. I'm an engineering partner at Blockstack. I've sort of been able to work across our platform on our Android SDK, our sort of MVP of that, our Mac app, sort of our JavaScript browser as well too. Previously, I was an entrepreneur based in South China. Still live in Hong Kong, so I ran a couple of businesses there. And I'm also a co-founder of the Bitcoin Association of Hong Kong, so in the crypto space for quite a long time. Today we're going to talk about problems with the internet. And then we're going to talk about what a decentralized app is, and then I'm going to tell you a little bit about what Blockstack is, and then we'll walk through some code samples of how you actually build a decentralized app. And finally, I'm going to try to sell you a little bit on why I think you should consider building an app on Blockstack. So first of all, I want to talk about some of the problems that we have with today's internet. And I'd like to actually sort of get your thoughts on this. If you have an idea of a problem with the internet that really bugs you, or that maybe is a problem for society, please raise your hand and someone will bring you a microphone. Over here? He's coming with a microphone. Hold on a second.
I think that corporations have more power than they should have, and I don't know, European Union, for example, can block access, or there's not so much free speech left on the internet, and it can be solved with decentralized internet.
Awesome. So you jumped exactly to one of my main points, which is I'm going to talk about power in a little bit. So we have corporations have too much power. It sounds like governments have too much power, and because of this, we don't really have the free speech that we used to have. One more person. Anybody else with an idea of a problem with the internet? Don't be shy. No? Okay. Well, we'll continue. So these are some of the problems that I see with the internet. We have these honeypots, right? We have these companies that have tons of user data, and they're just the perfect target for hackers. Financial institutions, sort of apps that collect a lot of personal data that could be valuable. We also see other problems such as tracking and data harvesting, right? Those ads that follow you around the internet and stalk you. It's really, really disconcerting as a consumer. And we also have users who are forced to make new accounts for every app that they sign up for, and they're really bad at choosing passwords. Most people don't know how to use password managers, so it's a really bad user experience, and it's a really insecure experience. And we have exactly what you were talking about earlier, this gentleman here in the front. Corporations have tons of power. As developers, they lock us into their platform. If we want to access a user's friends, we have to agree to Facebook's terms and service. If we make a really successful game that perhaps takes people away from Facebook too much, they'll shut us off, right? It makes it really hard for a small an indie developer or a small startup or even a medium-sized company to really be successful when we're sort of forced to compete with the Googles and the Facebooks of the world, and they have all of our data and all of our user data. Very difficult. And finally, there's the power, the fact that the power and the profits go to a few. And so today I'm going to talk mostly about power, just because I think it's most interesting. In the end, all of these things talk about power. I mean, the fact that we're locked in is power over us. So let's talk about power. Chairman Mao said that power grows out of the barrel of the gun. I think today, in the information age, power grows out of Facebook. It grows out of sort of this ability to have all of this user data and track activity on a daily basis and sort of see what people are clicking on, how they feel, and power over that. So this power has a lot of impact on our lives. Depending on what you post on sort of a social media product, you can potentially affect your career, right? So imagine you posted something 10 years ago that was maybe a little bit embarrassing, and then some algorithm decides that like, hey, like you've met this new boss and you're now working for them, and it surfaces this post from 10 years ago that you've forgotten about. And your boss sees this and is really unhappy. I can't believe I hired a person that would, for example, do this, right? That's really dangerous, right? And this power to track us and sort of know where we're going, it really hurts the most vulnerable in society, the people that like, for example, like are marginalized or sort of like disagree with the policies of the people in power. There's the power to like say like, hey, I'm gonna decide what apps you can use and what you can't. So when either Google or on iOS, when Apple decides, hey, I'm going to like turn off the ability for people to download this app. I don't like what you're doing on this platform. I don't like what you're doing with my Facebook API. I'm going to cut you off. That's a lot of power, right? And it really sort of like controls how we like are able to build our apps and how we can live our lives. There's also like the power to influence emotions. And so people have recently around the world started to realize that this is actually something that can influence sort of elections and policies, right? Like algorithms decide what to show to different users. And then based on those algorithms and who's paid like the person controlling the algorithms, like you can sort of influence popular opinion to vote for one candidate or another. And it's really, really scary. And there's also sort of like the power to overthrow governments, which we saw in the Arab Spring, where like people used platforms and they were able to organize, which is good. But there's this danger that like when the platform decides who can organize and who can't organize, where you can sort of affect real world outcomes in dangerous ways. So with all this power, there's a lot of responsibility. And so what I want you guys to think about today is like sort of a question, like think about your users. If you have an app and your app collects data, perhaps it tracks people, perhaps they can upload photos or videos, like what are your users uploading today and what sort of responsibilities does that data give you? Anyone who want to like hop in here and say like, hey, this is my app and this is what it's uploaded, people are uploading on my platform and this is sort of what worries me about that or responsibilities. Like raise your hand if you have anything, it's like, if you want to share that. Nobody wants to share? Oh, in the back corner, gentlemen. Hold on a second, microphone's coming.
Microphone.
We have telemetry, so our users send their user behaviors to us, like what feature they use most, stuff like that, and how they launch our app.
Okay, so what responsibility do you feel as a developer, as a business, for having that data? What worries you about collecting that data?
Because we want to know how they use our features so we can enhance or improve like our feature and prioritize our schedules to do stuff that really helps them.
But do you feel any responsibility? Do you feel any like, does it make you worried that you're collecting this data?
Yes, we have a review process. So every data we collect, we need to go through a review process.
Why do you have the review process?
So we want to make sure that this data is not, we have some levels of security concern. That first level is technical data, like performance information, and highest is like user identity, stuff like that. So we make sure we don't collect the stuff that we don't need, and how long we're going to collect, and the purpose of the collection is also important.
Excellent. So thank you very much. That's a really great example. So you have data that's collecting user activity data, and you have a review process because you're worried about the effects on privacy, and I'm going to also assume effects on some sort of laws, right, that sort of dictate of how you're allowed to collect user data. So that's a responsibility. So storing other people's data comes with responsibility, and that's something that we all probably are starting to know in the last couple of years. But I just want to sort of go through that quickly to sort of really show you what those responsibilities are. So first of all, you have responsibility to the law. You have to think, is this data the user is uploading, is it legal? And not only do you have to think about, is it legal here in Germany, you have to think about, is it legal any place my app is doing business, which could be thousands of jurisdictions worldwide. You have to think about like questions like, does the user own it? So Article 13 of the European Copyright Directive, if that sort of becomes law, right? We're going to have to look at what people upload and decide, is the copyright for this video or this picture, is it owned by someone else? And do we have a legal responsibility to prevent our user from uploading that to our server? We also have to think about whether or not the user has consented and opted in to our collecting of their data. So that's the GDPR law that many people talk about, right? We also have to think about, can we delete it? If they send us a request to either get their information or ask for us to delete it, have we structured our databases and our system in a way that we can easily delete it and it doesn't break the rest of our system? And how are we going to handle law enforcement requests? When we start having valuable data, eventually there's going to be a user on our platform that commits a crime or is being investigated, and some police department or is going to come to us with a warrant or some sort of other request that says, hey, I want to know about Bob's activities. Please give me all of where he's logged in from and all of the messages he's sent to Alice over the last 3 years. Do we have a process for that? That's a responsibility that we have to society. We also have responsibilities to our users. Is the user data safe from hackers? So when we're entrusted with people's data, they're trusting us, they're trusting our brand to make sure that this data is safe and is not going to be is going to remain private. When they send a private message, whether it's encrypted or not, they have an expectation that the whole world's not going to read their private chat. Is it safe from state actors? A lot of people use platforms from countries where they don't have a democratic government or they don't have the rights that we enjoy. And if their conversations or if their data or interactions or their documents was revealed to certain government entities, they could quickly end up in jail or persecuted politically. And are we by the rules on our platform, are we deciding hey, in this country we have sort of certain views, and we're going to enforce those views on everybody that uses the platform around the world, no matter what religion you are or what your local community views are. So that's sort of responsible to our users. I think that we shouldn't impose our views on other people. And are we standing in the way of their success? Is the user feeling our control of this platform is making it so they can't achieve success in their daily life? Maybe success for them is earning a salary, putting food on their table. And I really want to talk about that one a little bit, because there can be deadly consequences. A few months ago, there was a shooting at YouTube headquarters in California, because a woman was very unhappy that she felt that Google was sort of shadow banning her videos and not letting people view her videos. And because of that, that was hurting her livelihood and her small business. She got really sort of upset about this and found some weapons and went in and started shooting up the employees. And that's something I feel you never really want to put your business in that position, where you feel you have your users by the neck and they have no options but to take rash actions. So no one should have this much power, and no person should have this much responsibility, because it's a barrier to entry for small businesses, and it's just something that we should sort of let individuals that are using our platform sort of deal with themselves. And we think we can do better with decentralization. So I want you to think a little bit about a world with no data silos, the ability to move data between apps, no middlemen, no tracking, passwords that don't have to be made for every account that you log into, and no lock-in as a user. You can sort of be hey, I don't like this app anymore. I'm going to take my friends, my photos, my documents. I'm going to go over to this new app that's even better. I don't have to recreate my digital life. So yeah, I think it's going to be a really great world where we're able to move our data between apps. And as we move on, we're going to talk about how we actually implement this. But one of the things I want to talk about is we want to make a world where if someone has a problem with you, they actually have to go to you, as opposed to be hey, I have a problem with Bob. I'm going to go to Google and shut down his account or request his data. And we also want to imagine a world where the platform where people love to share their cat pics isn't so important to society that that's changing elections, and it has the potential to overthrow governments, because that's kind of crazy. So let's talk about how we decentralize now. I like to think about decentralization as putting users in control of their data, removing trusted third parties. So these are people that are not party to the relationship or transaction the user is conducting, and a proper set of incentives that incentivize people to sort of break free of the network effects of the centralized internet and either build or use new decentralized apps. So what does this mean for apps? When you log into a decentralized app, your app is told a few things. It's told where to store user data. So you don't store the data on your servers. You store the data in the user's private cloud, in their storage hub. And when a user logs into your app, you get told this is where you should store the data. You're also told how to encrypt the data so that only the user can decrypt it. You're also told who the user is, and then you're given a method to interact with other people that are using decentralized apps. And to do this without any third parties or middlemen. So a couple words about what Blockstack is. Blockstack is a developer platform to help you build decentralized apps where users control their data. And the way you can think about it is like the internet is already decentralized on sort of like the first 3 layers. The link layer, like your internet, your Wi-Fi or your Ethernet cable, IP addresses, TCP/IP. But the application layer is where most of the centralization has been happening. So the social graph, ability to like interact with different people on the internet. And we are trying to decentralize the application layer. And we do that with a bunch of technology, which I'm not going to dive in too much to today. But at the base, we use a blockchain. And then we have sort of like all these different pieces of technologies that work together to give you a trustless way to find storage and identity and to authenticate users in a way that's on the surface very easy for developers, but underneath there's a lot of complexity. And just to give you an idea of how the Blockstack network looks, Blockstack nodes are connected to Bitcoin nodes, and they get their sort of like root of trust from the Bitcoin network. They can work with any blockchain, public blockchain, and then users and apps, they talk to Blockstack nodes, and that's how they get their view of the universe. That's how they figure out like where one person's storage is, how to interact with other users, and that's how they verify that a person is who they claim to be. So Blockstack hides all of this complexity, storage, identity, naming, blockchain transactions from developers, and gives you a really nice API on Android, on iOS, and JavaScript. So like now let's get into like what are the parts of a decentralized app. So I think that there are 3 main parts. Authentication. That's the ability to prove who a user is on the network. Encryption, the ability to like have a random key, private key that's specific to the app so that you can do various operations with that and like store data that only the user can read. And then storage, a way where the user can specify where the data is stored in a way that only the user controls the data that's stored there. Your app is not responsible for either holding the data and doesn't even have to touch it if your app is only running on the client device. So to do this authentication, the first thing you need is identity. You need to know like who are these people that are using our apps. And in typical applications, we typically have like some sort of user management system, a database, a table, a username, and password. Well, we don't have that on the decentralized internet because to have something like that, we would have to have a trusted party that runs that database and that attests that, hey, this person, Bob with the password 123 is actually the real Bob, right? And we don't want to have that party. So we have something called Blockstack IDs that are decentralized identity. And what a Blockstack ID is generated from a cryptographic sort of phrase, a 12-word secret recovery key, which is used to generate a private key. Before I jump into this, I want to want you to raise your hands. Who's familiar with public-private cryptography here? Okay, about a little over half. So for those of you that are familiar, what this phrase is used to do is to generate a private key. And then from that private key, we're able to use, through key derivation, we're able to derive a series of child keys. And these child keys are used to represent identities. I can point you to more resources if you'd like to learn about that later, so please find me. But this is a sort of a visual of a Blockstack ID. And you'll see that we have something here called the identity address. And what that is that's a representation of the public key that corresponds to the private key that was generated for this particular identity. It's globally unique, and only this one person has it. And we also have a username that is sort of purchased and bought and assigned through the blockchain that corresponds to this identity. So it's a human-friendly way to like find this particular identity. And you see here you can do things like verify various social accounts with a Blockstack ID. This lets people know, like, hey, I'm looking for, you may be friends with somebody on Twitter, but not know they're on Facebook, and it lets you sort of get an idea as to who this person is. And it prevents civil attacks. It prevents other people from making names that are similar to yours and pretending that you're you, because you have a trusted sort of web of verification of various accounts that are owned by that person. So now let's jump into how we add this to our Android app. A couple like prerequisites, if you will. First of all, I want to just make sure everybody knows this is based on a particular version of our SDK, especially those of you that are watching at home. That the interface is going to change over the next few months. So these examples specifically only work with this particular version of the SDK. We use Kotlin, and we also assume that you already have a website for your Android app. That's because part of our authentication process involves verifying control over a domain name. So the first step to adding Blockstack to your Android app is to add the SDK to your imports. Pretty straightforward. The next thing we want to do is in our main activity, we want to create a Blockstack session. And what this Blockstack session does is it represents sort of an instance of a user being logged into a particular app. And there are a couple variables that we set when we're doing this. We want to set the app domain. The app domain is actually the identity of the app. So an app is different from another app if the app domain changes. And what we do during the authentication process is we send a redirect to a website to verify that the Android app actually corresponds to that app domain. And we have some other variables we can set as well too that talk about where the redirect endpoint is on the website. And we also have something called a manifest file, which is taken from the Progressive Web Standard. And it has information like your app's name and an icon that are displayed during the authentication process. So it's pretty straightforward. And there's also an onloaded callback. And you want to make sure that when you use any API methods that you do that after the onloaded callback is fired, so that everything is initialized. So what I'm going to do is I'm going to walk you through this from a user perspective and then show you the code and sort of the underlying data structures that appear as this happens. So first of all, you want to add a sign-in button to your app. And we have a nice themed sign-in button here you can use if you so desire. And when the user taps on that button, what happens is this code is executed. You have a sign-in button, right? And then when it's clicked, it calls this redirect user to sign-in method. And what this method does is it opens a sort of a web view. It opens a Chrome tab, a custom Chrome tab inside of your Android app. And that tab loads a hosted version of the Blockstack browser, which is an authenticator app that users' identities are stored in. And when you click on that sign-in button, what happens is a JSON web token is generated in a particular format. And this is an example of that JSON web token. Everybody familiar with JSON web tokens here? Anybody? Okay. It's more of a web technology. It's basically like a data structure that has, as you can see, has structured data. And it also, this is the unpacked payload version of it. It also includes, it's encoded as a string, so it looks like a long jumble of letters and numbers. And at the end of that, there's actually a signature. And that's what kind of makes it unique and makes it magic, is that we can put a bunch of payload data in a string that's signed. And it's possible to verify that token. So in our particular payload for our authentication request, we have a bunch of information here. We have information about the app and public keys and the domain name of the app and the redirect URL. We also have a special variable called scopes, which is indicating to the user's authenticator, the Blockstack browser, what sort of permissions this app is requesting. So what happens from a user perspective is they see this Chrome tab in their app, and it asks them to select a Blockstack ID to authenticate with for this app. So they tap on that app, and what happens is another JSON web token is generated, similar format, and this token is signed with the user's ID private key, so that we know that it came from a particular Blockstack ID. And then it includes sort of the expanded version of the public key so that someone's able to verify that the signature matches a specific public key. And then since you have the public key, you can also calculate the identity address, which we also include in the issuer key up on the top. And so we can look at the identity address, and we can do a lookup with a Blockstack node, see what names are owned by that address, and then we can verify that the username that the person claimed here is actually valid, and they're not spoofing someone else's identity. Additionally, we have some other information here, which is interesting. We have a private key, which you see that I've redacted here in this example. And that private key is pretty unique. It's an app-specific private key. It's unique for every user and for every app that they use. And that private key enables a whole bunch of other things that we're going to talk about in a few minutes. The next step on your app is to add an intent filter to the manifest XML file. And what this is going to do is you're going to want to make a custom schema for your particular app. You can also use custom intents, which is something we don't support in this version, but we will in the future. And this is a way to indicate to Android that it should handle the redirect back from that cron tab and process the authentication request. After that, we have to add a handler for the authentication response. This is probably the largest block of code I'm going to put in the screen here, so apologies for that. What this does is it catches that custom schema. So when that custom schema is handled by your app, that intent, I'm sorry, it executes. And then what you have to do is you parse out the authentication token, which is pretty simple. You just split it by the colon. And then you send it to this handle pending sign-in function that you see here on line 80. And what that does is that performs all the verification steps I just talked about. It verifies the signature, it verifies name ownership, it decrypts the private key, it populates a sort of a data structure with user data, with profile data, their name, their bio, their profile picture. And it gives us all this nice stuff that we can use in our app. So global unique identifier, cryptographic proof that the person is who they claim, an app private key, the ability to access the user's storage hub, their private cloud storage, if you will, the ability to access multiplayer file sharing, and access to their public profile. So let's talk a little bit about app private keys. The app private key is a unique private key. So again, it's a unique for each app user combination. And we can use that to do anything sort of cryptographic that you'd want to do. We by default use it to encrypt user data. So when you store data using Blockstack, that data is encrypted so that only that user in your particular app can read it. If you want it to be readable by other apps, you have to explicitly opt out of that. So from a user's perspective and from a developer's perspective, you don't have to touch user data by default with Blockstack. You can use it for cryptocurrency wallets, making an Ethereum wallet, making a wallet for your favorite token. You can use it to encrypt other data. For example, you can share the public key with a friend, and then you can have them that user encrypt data for you using that public key. Here's a quick example. This is JavaScript, so I'll apologize for this. But it's how you make an Ethereum wallet using a Blockstack app private key. 3 lines of code, pretty simple. Finally, you get storage. And so on Blockstack, storage happens through what's called a Gaia storage hub. And that storage hub you can think of as a private cloud. Each user has their own, and they can choose if they want to host their own or have someone else host it, and they can run it on their own premises if they choose. Think of it like S3. It's basically you get an app user-specific bucket. So each app gets their own bucket, and you can control whether or not someone can write to that bucket based on which app and which user is signed in. That data is unique in that it's world readable. So if you don't encrypt it, the whole world can read the data, which enables some unique sort of interaction sharing techniques. The data on the back end, it's a very simple system, so it's only like 150 lines of code, a Gaia hub, and it's backed by commodity cloud storage. So it's backed by S3, Azure, Google Cloud, your own sort of NAS at your home. And it enables sharing without trusted third parties. So you can share with other users in your network and do it without touching any companies in a way that you're trusting. So no entities are being trusted between the user's device and the files you're trying to read. So how do we add that to our app, encrypted storage? Pretty simple. We use the Blockstack session, and we call the put file method. We pass an an options object to that that we've created above. And then we choose a file name, messages.txt. And in this instance, the content we're writing is a simple string. It could be a JSON object. It could be a binary file like an image or something like that. And what's happening here is this is by default getting encrypted on your Android device, before it's posted to the user's Gaia hub and it's written. And you can see that I'm updating a text view component there, which with the read URL. And what that is once this message returns and the file is written, you get a world readable URL to that specific file, which you can use in your app for whatever you need it for. Reading a file is the same. So you create an options object, and then you use the getFile method. You tell them what file name you want, and then you get either a string or a binary file back from that as well too. So it's pretty straightforward. If we take a little deeper look at the options object, this is an options object for the getFile request. There's a bunch of things that we can configure here. We can decide if we want to turn off decryption. If we want to make a file world readable, we would turn off decryption. I'm sorry, in this case, if we were reading a file that was not encrypted, we would want to turn off decryption. If we were writing it, we'd want to turn off encryption. You can specify a username. So for example, say my name is Bob, and I've written a file to this particular app. If I want to read Alice's file, message.txt, I would create an options object here, and I would specify alice.id as the username, and I would pass that into my getFile request. And that way I could easily read Alice's message.txt file without having to go through any trusted third parties. And what happens when that happens is a zone file lookup is done, which is a particular type of file in Blockstack. And you can see you can specify the server or the node that's conducted on. So you could run your own node and then do a lookup on that node and then get a response as to where Alice stores her messages.txt file. It's pretty cool. It's pretty simple from a developer perspective. So any questions on that so far? No? With me? Okay. One question here? Yeah. Thanks for running.
So what I'm wondering is, like, you use private public keys for authentication and encryption, obviously here. Mm-hmm. If I'm using Blockstack now, do I have to set up my own PKI, or do you provide a PKI? Because PKIs are pretty expensive.
Yeah, you don't have to set up your own. So PKI is public key infrastructure, I believe. So the question is, do you have to set up your own? So this is a decentralized system. So with a public key infrastructure setup, PKI setup, you typically have a certificate authority, and that's a trusted third party. They issue certificates, and they attest that, hey, like Bob is Bob and Mary is Mary. But in the Blockstack world, anybody can generate a public-private key pair. There's no certificate authority. Nobody is attesting. At least no central entity is saying, hey, this person is who they say they are. So what happens is you generate this random public-private key pair, and you buy a name, which you choose. Names are globally unique, but you choose what the name is. And then you establish a reputation around that name. So in my instance, I connected all of my social media accounts to this, and I verified on those accounts, hey, like on my Twitter, I made a tweet like, on Blockstack, Larry is Larry.id. And so all these pointers going back and forth allow people to independently sort of get an idea of who this person is. One thing you could use these for in the future is, right, if you, for example, maybe you're in a school or you live in a country or a place where the government wants to verify this person is who they say they are, they could sign something with their own private key attesting that like Larry.id is actually Larry and he lives in Hong Kong. Right, so that's a way that you could sort of bring on that centralization, if you will. Answer your question? All right, thanks. Okay, cool. We're running short on time, so just quickly, a couple words on why I think you should build on Blockstack. There's a growing market for decentralized apps right now. People are finally starting to realize the impact of the information age on our like day-to-day life and our physical reality. So there's like a niche like market for people that care about this, and it's growing every day. A lot of people are also care about their portability of their data, ability to like not get locked in. Businesses in particular, like it's nothing worse than a business than like buying a particular SaaS platform, investing a lot of money in it, and like getting people on board and deciding, hey, like it's not working, and you have to recreate your data somewhere else. Another thing is there's a new decentralized app store called app.co, where you can get your app listed. There's not a lot of apps at the moment, so it's sort of early days, and it's like kind of a land grab, so you can sort of make a new app and sort of make a reputation for yourself for having a great new decentralized app. We have a pretty good developer experience. We try to make things very simple. We try to hide a lot of complexity so that you don't need to be a distributed systems engineer to make it a centralized app. And also there's something called app rewards mining, which is going to be launching probably later this year or next year. And what that is that every time a block on Blockstack is mined, money will be paid out to app developers. And that will be distributed by a team of app reviewers that will sort of rate apps based on various metrics that they come up with. So the interesting thing about that is that's $1 million per month in the value of our token from last year. So like that's going to happen if there are no apps or if there's like 1 million apps. So if your app is there early, you have the potential to sort of collect a lot of value out of that. And so help to bootstrap potentially a new business for yourself. Yeah, and like everybody else at this conference we're hiring, we would love to have a lead Android developer to take over our SDK and to create a Blockstack Android app. I think we're a pretty interesting community and team. We'd love if you're interested in joining. If this like project sort of like strikes a chord with your sort of political views or your views about how society should function, like please come up and talk with me. We'd love to sort of engage you. And keep in touch. Thank you very much. If you scan this QR code, you can leave your email and I'll send you these slides. And I'll also send you a tutorial we're working on for Android that's sort of more detailed and I'll make it really easy for you to make your first app. We'd love to keep in touch with you. Thank you very much. Questions? Yeah.
We still have 5 minutes, so really, if there are questions, just ask them. Yay.
So I think you're building on Ethereum tokens. Is that correct, or is like you have your own blockchain?
We're building a proof of burn blockchain. So it's not an Ethereum token. It's based on our own technology. And what that does, a proof of burn blockchain is a blockchain that's mined by burning Bitcoin. So our system, our production system has been running on top of Bitcoin for, I want to say, 3 to 4 years. We have about, I think, 70,000 or so names registered over the past couple years. And we're building our own blockchain that's going to mine blocks and sit on top of Bitcoin, and the way you mine the blocks is whoever burns the most Bitcoin for a particular block gets to be the person that mines that block. To answer your question?
Yeah, that was the question leading to another one actually, to scalability issues and to bottlenecks like networking issues and stuff. Sure,
so gentleman's question is about scalability issues. For those of you that are not familiar with blockchains, scalability is a huge concern. Particularly in platforms with smart contracts where you put the code in the blockchain. You essentially have created a world where if a user opens an app on their phone, they have to open the app on all of the computers in the world. So it's not scalable. So we take a really different view here at Blockstack. We try to use blockchains as sparingly as possible. So in all of the things I talked about today, the only place that we use a blockchain is in the looking up of the name, is actually registering the name. The only time you ever have to make a transaction on a blockchain is to register a name, and we even have a way to provide those for essentially free by batching lots of them together and making one transaction. All of the storage, reading and writing data, all of that stuff your app does, you don't have to do anything with a blockchain. It's totally free, there's no cost.
So then that means that all the identity storage is then Blockstack's infrastructure?
No, I'm happy to get into this with you later, but the identity is based on, it's all in the user's on the user's computer, right? So they have their private key, right? And that has a public key. And then the connection between the name and then the public key is stored in the blockchain. So that comes from registering the name. And then beyond that, the lookup all happens, it happens through a Blockstack node, but it's nodes that people can run. And I'm happy to jump into the details of that after if you want to. Yeah.
Still had someone, he was there first, so.
How does your storage Gaia compares to the one developed by Cryptello? I'm not sure if you've heard of it.
No, I haven't heard of it. What is it called?
Cryptello. It's a startup, but they are basically working on a storage based on the blockchain technology. So.
Okay, yeah, I'm not really familiar. It's important though to think about our storage. Our storage, we only use, the only place a blockchain comes into play is to looking up where a particular user's storage is in a trustless fashion. To actually read and write data, we don't use blockchains at all. Again, because blockchains are really bad databases. They're really expensive, really slow. Yeah.
Okay, then last question before the coffee break. Go.
Article 13 is not yet in law,
Yeah.
so you can still call your member of the parliament and prevent that.
Thank you. I will make sure I do that. Yeah.